Hello everyone, welcome to my YouTube channel. And today we'll be talking about the skill that replaced prompt engineering. So, you have been optimizing the wrong thing till now. The last 2 years of AI development have been dominated by the prompt engineering. Find the right words, add the chain of thought, use few short examples, tweak the system prompt, and all of that is useful, but is the smallest lever in the system. The builders shipping production AI in 2026 aren't arguing over prompt phrasing. They are architecting what goes into the context window before the prompt is ever written. That discipline has a name, which is called context engineering, and is the real reason some AI systems work reliably in production while others fall apart. So in this video, we are going to build a complete mental model for context engineering, what it is, the four components that make it up, the three laws you cannot break, and exactly how it connects to everything we covered in this series. RAG, chunking, evaluation, all of it. So let's go. So let's start with the definition. There are a few good ones floating around, and they're worth knowing because each reveals something different. Like Andrej Karpathy, okay, ex OpenAI, said that context engineering is the delicate art and science of filling the context window with just the right information for the next step. Shopify CEO Tobi Lütke says that the art of providing all of the context for the task to be plausibly solved by the LLM. Anthropic engineering team says context engineering refers to the set of strategies for curating and maintaining the optimal set of tokens during LLM inference, including all the other information that may land there outside of the prompt. So you notice the pattern across all three definitions. It's not about the word in your prompt, it's about what surrounds the prompt, what information the model has when it starts generating. So the one line distinction, so let me tell you, here's the clearest way to say it. Prompt engineering is what you say to the model. Context engineering is what the model knows when you say it. Okay. So the prompt engineering is a subset of the context engineering. You still need a good prompts. Okay. But prompt engineering alone maxes out fast because a brilliantly worded instruction still fails if the model is working with stale data, irrelevant retrieved chunks, or a context window polluted with noise. So the context engineering is upgrade from one-shot tinkering to system design. Is the difference between asking ChatGPT to write an email versus building a customer support platform that maintains conversation history across sessions, retrieves the user account details, and remembers their previous tickets. As a key point, we can say that LangChain's 2025 State of Agent Engineering report found that 32% of the organizations cite quality as their top AI agent barrier, and most failures trace not to LLM capabilities but to poor context management. So the model isn't the problem, what you feed is. So let's move on to the component of the context. Yeah. So every token that enters an LLM context window comes from one of the four sources. Understanding these four components is the foundation of context engineering. One is system prompt, second is retrieved chunks, okay, third is memory, and fourth is tools. So system prompt is the instruction role, rules, or persona that you give. Like for example, you are a helpful assistant, always cite the sources. Okay, here you have full control because you write it. Next is the retrieved context, which is the external knowledge pulled at query time. So through RAG, like for top 5 chunks from your vector DB. So here also you have full control because you have the design, you design the pipeline. Next is the memory. So it is the conversation history or the past interactions. So previous 10 terms of the dialogue is an example for that. And you have full control here also because you decide what to keep. And the final is tools. It is the definition of callable functions or APIs like search, get weather, run SQL maybe. Okay, so you have full control here also because you choose what's available. Every single one of this is under your control. The LLM is a fixed function, so you cannot change the weight at inference time, but you own every token that enters the context window. That is the entire game. So let's deep dive here. In the system prompt, okay, the system prompt says the model's operating mode, okay, its role, its constraint, its output format, its personality. So most engineers treat this as a static text block. They write once and forget. So context engineers treat it as a precision instrument, short, direct, and right level of abstraction. Anthropic's engineering team specifically warns against over-engineering system prompts with complex brittle logic. The more hard-coded rules you had, the more fragile the system becomes. Favor principles over rules. Next component is the retrieved context. Okay. So this is where the RAG lives. Everything we have covered in this series, vector database chunking, hybrid search evaluation, it all serves to that one component, that is the retrieved context is a dynamic knowledge you inject at query time. It's what lets your model answer questions about your private data, your latest documents, and your real-time information. Context engineering asks harder questions. Then did I retrieve the relevant chunks? It asks, are these right chunks in right order? Are they redundant? Do they contradict each other? Are they too long? Are they positioned where the model will actually attend to them? Next comes memory. So memory is an information persisted across turns or sessions. So short-term memory is the conversation history in the current session. Long-term memory is the information that is stored externally and retrieved when needed, like the user's preference, past decisions, or previous session summaries. Okay. So the context engineering problem with memory is you can't keep everything. Conversation history grows linearly with every turn. If you inject the full history every time, you will hit your context limit and flood the model with low signal tokens. Context engineers design explicit memory strategies, what to summarize, what to discard, what to store externally, and retrieve selectively. So the last part is the tools. Every tool definition you give a model consumes token before a single word of user input arrives. An agent with 20 tool definitions and is burning significant context budget just on description, parameters, and examples. Context engineering asks, which tool does the agent actually need for this task? A good context engineer doesn't give agents all the possible tools. They give agents the minimum set needed for the current task loaded dynamically when needed. So let's move on to the next slide, which are the three laws of context. Okay, these are not guidelines, these are the physical properties of how LLM actually works. Okay, so violate them and your system will fail in production regardless of how well worded your prompt are. So first law, context is a finite resource with diminishing returns. Context window have grown enormously. Okay, 1 million plus tokens are available now, and a common failure mode is thinking that bigger window is equal to better results. Just throw everything in there, right? So it's wrong. It doesn't work like that. A Databricks study found that accuracy starts degrading around 32K tokens long before you hit a 1 million token limit. Chroma research also tested 18 LLMs, including Claude, GPT 4.1, and Gemini 2.5, and found consistent performance degradation as a context source, even on the trivial simple task. So the phenomenon has a name, context rot. So context, as the number of token in the context window increases, the model's ability to accurately recall information from that context decreases. More token equal to diminishing attention per token. The implication is that treat your context window as a budget, not a dump. Every token you add, you justify its presence. The goal is the smallest set of high signal token that maximizes the probability of the right output, not the largest possible set. So let's move on to the next slide. That is the second law. Position matters as much as the content. So the Stanford Lost in the Middle research proved this empirically. LLM performance degrades significantly when the relevant information is buried in the middle of a long context. Model attends most strongly to the information at the very beginning and the very end of the context window. Information in the middle gets systematically under attended. So this has a direct Implication for every RAG system, if you retrieve 10 chunks and inject them in arbitrary order, the 5 most relevant chunks might all land in the middle. The model will underweigh them. Context engineering means being deliberate about position, putting the most relevant retrieved content first, keeping the instruction close to the query, and not letting important information get lost in a sea of mediocre chunks. Next comes the law 3, that is conflicting context breaks everything. 4 distinct failure modes have been identified for what happens when the context goes wrong, like poisoning, which is the irrelevant information distracts the model. Second is distraction. So slightly off topic content pulls the model away. Third is confusion. Contradictory information creates ambiguous outputs. And fourth is clash. Two pieces of retrieved context directly contradict each other. So this is a major reason why naive RAG system fail on a complex query. You retrieve 5 chunks, two of them say different things about the same entity, and the model either picks one arbitrary or hedge. So good content engineering includes conflict detection, checking for the contradiction in the retrieved context before injection. So this 3 law summary table, to summarize about that, let me show you in here. Yeah. So you can take a screenshot of this. So context is finite. Okay. That's why quality is greater than quantity in the first law. Okay. Accuracy drops as the context grows. So the fix is we have to compress or filter or prioritize. Next, second loss is position matters, the most relevant content first and last. So the model ignores the best retrieved chunks. So we need to re-rank before the injection. Third is no conflict, contradictory context produces bad outputs, inconsistent or hedging answers are like symptoms. And we need to deduplicate and conflict check retrieved docs also. So let's go to the next part, which is how this connects to your RAG pipeline. Okay. So here's the insight that should make this entire series click into place. RAG is the context engineering for the retrieved context component. Every video in this series has been about different aspects filling that component well. Okay, like vector database where you retrieve knowledge lives. RAG evaluation or RAGAs, are you filling the context with the right content? Graph RAG, alternative context structure for relational queries. Synthetic test data, the testing whether your context filling strategy actually works or not. But the context engineering is a bigger than a very vast subject than a RAG. So it encompasses of all 4 components. A context engineer looks at the token budget and asks, given that I have a memory tool, a system prompt, and a retrieve doc, all competing the space, was the optimal allocation. So real production example, if your tool definition are eating 2000 tokens and your system prompt is eating 1500 tokens, you have already spent 3500 tokens before a single retrieved chunk arrives. For a model with effective context rod around 32K tokens, the 3500 tokens overhead is meaningful. Context engineering means auditing your total context composition, not just one component in isolation. So practical technique, which is context compression, is a solution for this. Before injecting retrieved chunks, use a smaller, cheaper LLM to summarize each chunk relative to the current query. You can often reduce a 500 token chunk to a 80 token while preserving 90% of the signal. So this is one of the highest ROI technique in production RAG right now. So let's move on to the next slide, that is hot takes. Okay, so the industry truths for production AI builders. So first hot take is the prompt engineering was always a misleading name. The people who got the best results from LLM were always doing context engineering. They just didn't have a name for it. They were curating examples, structuring retrieved docs carefully, managing conversation histories. So the obsession with the prompt phrasing was a surface level distraction from the deeper system problem. Second hot take is a bigger context window is not as suitable for context engineering. So every time a new model drops with a 2 million token context window, people say RAG is dead. Just throw everything in. So context rot is real. Performance degrades well before you hit the limit. The model that wins in production will be the one with the smallest, highest quality context, not the one with most tokens stuffed in. Third hot take, most AI agent failures are context failures, not model failures. When your agent gives a wrong answer, you first instinct is to switch the model or tweak the prompt. But Langchen's data says that 32% of the quality failures trace to context management. Before you upgrade your model, audit your context pipeline. You'll fix more bugs with better context engineering than with a better LLM. So the last hot take, that is context engineering is most valuable skill in AI right now, and almost nobody's teaching it properly. So you can find thousands of tutorials on prompt engineering. You can find courses on fine-tuning RAG and vector database, context engineering, the disciplines that ties all of it together. Get one blog post buried in Anthropic's engineering notes. The builder, the builders who internalize the mental model in 2026 are going to be the one shipping reliable production AI, while everyone else keeps tweaking prompts. So, let's recap. Okay. So here's the mental model to carry forward. Context engineering is a discipline of filling the context window with the right information in the right format, in the right position at the right time. Four components are there: system prompt, retrieved context, that RAG, okay, memory, tool, all complete for the same finite budget. There are three laws: context dot as it grows, position determines the attention, conflicting context breaks output. RAG is the context engineering for the retrieved component. So the rest of the series taught you how to do that one component well. The next frontier, treating all the four components together as a single engineering problem. So if you want to go deeper on this right now, Anthropic published an engineering post called Effective Context Engineering for AI Agents. Is the best technical treatment of this concept available today. Link is in the description. Comment the prompt. Okay, what is the biggest context problem your RAG or agent system is facing right now? Too much noise, contradictions, memory overflow? Drop it below. I'm genuinely curious what the community is hitting. Next up, there are a lot of things that are coming up in AI, and to be in the frontier of the AI field, let's join together and keep on learning. Stay tuned.